Hello everyone, welcome to the session and welcome to my channel Aptitude Club. So this is the third session of the remainder series. If you haven't watched the previous two sessions and you are watching this session for the first time, I would suggest please watch the first two sessions where we have discussed basic remainder theorem, a little bit concept of negative remainders, and then Fermat's little. So the three things that we have discussed in the previous session. Very basic level discussions we have had, and we did solve a few examples to understand how these theorems are utilized and applied while solving questions on remainders. Today's session is a continuation of those two sessions, where we'll take up questions on continuous digits. I didn't know how to name those questions because digits में ये जो questions आते हैं वहाँ पे will have continuous digits. So that is why I named it as continuous digits remainder questions. And we do get some questions on this part on like various exams. You can see we'll have questions on continuous digits and find the remainder when this is divided by that. वैसे करके आता है. So that is why this session is completely dedicated to continuous digits. Just a second. And in this continuous digits like session, we'll take the questions based on two theorems. एक तो basic remainder theorem will be using. Okay, continuous digits में one basic remainder theorem I'll use and उसमें एक type का question है, and then the next part will be Fermat theorem. Like Fermat theorem में continuous digits questions, how are those questions asked and how you should solve them. Okay, so sincere request, please watch the previous two sessions if you haven't, and I'll pin the session links on the description of the video. Also I section में I'll pin the basic remainder theorem first session का link because that is the most important thing to know. Every other theorem is built from that theorem only. Okay, so do watch that. So without further delay, let us begin. So let's take a look at the first question. Find the remainder when 212121 up to 160 digits is divided by 99. All right, this is what is called as continuous digits. I hope all of you get this logic now, why I called it as continuous digits, because this 212121 it is repeated till 160 digits. So how do you solve these kind of questions? Like simple sa shortcut hai. 3 steps you will get the answer of such question. But to be able to use that shortcut, you first need to know how these questions are normally solved. Like let us say we don't know the shortcut, so what should we are thinking? So first let us go to that. Now look at this. If I take only 21, I can write it as 21 into 100 to the power 0. The same thing. But why write it in this way? So that when you take 2 units of 21, 2121, so then I can use this pattern and write it in this way. 21 into 100 to the power 1 plus 21 into 100 to the power 0. So this becomes 2100 plus 20. If I take 3 units of 21, it becomes 21 into 100 square plus 21 into 100 to the power 1 plus 21 into 100 to the power 0. So this gives us a very important pattern. So when you are taking 21 only once, मतलब एक unit ले रहे हो, the power of 100 starts from 0. When you are taking it twice, 2 units of 21, power of 100 starts from 1 and goes till 0. When you are taking 3 units of 21, it starts from 2 and goes till 0 and so on. So now when I have 160 digits, so I will have 80 such units. Yes or no? 21 will be repeated 80 times. So that means this number 2121 up to 160 digits. How can I write this number? Same number can be written in this way. I can write it as 21 into 100 to the power. I'll start with 79 because I'm seeing that the number of times 21 is repeated. Power of 100 starts from 1 less than that. If it is repeated 2 times, मैं power 1 से start करके 0 तक जा रहा हूँ. If it is repeated 3 times, I'm starting it from 2 and going up to 0. So now it is repeated 80 times, 21. So I'll start from 79 and go up to 0. I hope all of you are able to understand this. Very simple process. 100 to the power 77 and so on till this 100 to the power 1 and last में 21 into 100 to the power 0. Pretty simple process, and I can say okay, each term, general term here in the expansion, pretty much like this, 21 into 100 to the power something. This is the general term pretty much. Now when this total expansion is divided by 99, this is essentially a sum. जितने भी terms है सबका sum है, and we know that remainder of a sum is equal to sum of remainder. You pick any normal term, like any general term. तो वो 21 into 100 to the power n divided by 99. Any term divided by 99. Any term is of the form 21 into 100 to the power n. उसमें 99 divide करोगे तो remainder 100 to the power n divided by 99, remainder तो 1 ही है. Because 100 divided by 99, remainder 1. फिर तुम 1 को जितना टाइम लोगे वही remainder 1 ही आएगा. Whereas 21 divided by 99, remainder is 21. So I get 21 into 1, 21. I hope all of you are able to understand this. If you are not able to understand this, please watch the first two theorems. ये बहुत ही easy चीज है. 100 to the power n means 100 into 100 into 100 into 100 n times multiplied by. Every time 100 is divided by 99, remainder is 1. So 1 into 1 into 1 n times. The remainder of a product is product of remainder. That principle we are using. So once you understand this, then the question is solved. अब देखो मैं ये लिख सकता हूँ. Let me write it here in this way. 212121 up to 160 digits when divided by 99 can be written in this way. That is 21 into 100 to the power 79 plus 21 into 100 to the power 78, and like this till 21 into 100 to the power 0 divided by 90. Now this is a sum, and I'm seeing that every time you are dividing any term, ये term हो जाए, remainder 21. Here also the remainder is 21. Here also the remainder is 21, because 100 to the power n divided by 99, the remainder is always 1. Doesn't matter तुम 100 का क्या power ले रहे हो, remainder 1 ही आएगा, because 100 divided by 99, remainder is 1. Make sense? So that means every term is giving me 21 remainder. So 21 plus 21 plus 21. How many times? 80 times. Because here I'll have 80 terms. 160 digits. 2 digit लेके एक term आ रहा है, तो 80 terms. So 21 into 80 हो रहा है, which is basically 1680. But 1680 cannot be the remainder. Again, why? Because remainder is always less than the divisor. Remainder has to be always less than the divisor. तो 1680 को वापस से 99 से डिवाइड करोगे, तो 80 plus 16, you will get 96 as the answer. Okay, ये कैसे हुआ I'll tell, but I hope all of you understand this step. So next time we see a question like this, अपना question बस इतना तक ही है, बस ये देखना है 21 आएगा, how many times, and then just solve करना, just this much. Next time onwards we'll only solve this much. We don't have to write the expansion every time. If first time you are solving this question, so I like explained the entire expansion and how it happens, but I'll tell a very simple shortcut. So 3 step में इस type के questions. But before getting there, let's take a look at this. When you are dividing any number, let's say ABCD एक 4 digit number है, उसको 99 से divide कर, तो ये property just not 99 के लिए, 9, 99, 999, any series of 9 में जब तुम divide कर रहे हो, जितने 9s है, there are 2 9s, so you take 2 digits from the right and put a divider and add these two, AB plus CD. This is your remainder. Just from the right you take 2 digits. Why 2 digits? Because there are 2 9s. अगर 999 होता तो you would have taken 3 digits from the right and put a divider. So if I use that here, 1680 divided by 99, so 80 plus 16, I get 96. Suppose I'll write 4530 divided by 99, so 30 plus 45, the remainder is 75. Very easy process to divide by 99. And I hope all of you understand this. थोड़ा tricky लग सकता है if you are just watching this for the first time. So my suggestion, please watch the previous 2 sessions as well. But these are very, very, very easy questions once you understand how basic remainder theorem works. Okay. So let me write the shortcut for you. What is the shortcut for such question? The shortcut is you can directly find the remainder in this way. Remainder R is basically the repeating unit into the number of repetitions divided by the divisor. Simple इतना ही करना है. Repeating unit into the number of repetitions divided by the divisor. So for an example here, if I take 2 1 2 1 2 1 up to 160 digits, what is my repeating unit? Repeating unit is like 21. Number of repetitions, it is like it is being repeated 80 times, and the divisor is like 99. So the simple remainder is repeating unit into number of repetitions divided by 90. So 1680 divided by 99, the remainder is 90. Very simple, and just इतने में ही solve हो जाएगा. But थोड़ा सा क्या चाहिए यहाँ पे, that for applying this shortcut, there are a few conditions that should be met. Conditions is, first this number must be symmetric, and the second is 10 to the power n divided by the divisor, the remainder must be 1. So you expand in n digits. Expand in n digits. I'll explain what this is. Maintaining the symmetry. So what are these two conditions? अभी मैं जो question दिया हूँ, directly वो conditions are met. Okay, the condition satisfy हो रहा है. You just have to apply the shortcut. Now conditions अगर meet नहीं किया तो क्या होगा? Now these are like a gradual follow-up questions. But उतना deep तो पहले exam में पूछेगा नहीं, because this itself is in a difficult level. उससे और आगे जाके exam में they will not ask. But even if they do, you will figure out how to do it. I'll explain that also. But what do you mean by these conditions? The first condition is number is symmetric. The number should be symmetric. Symmetric का मतलब है यहाँ पे look at this 2 1 2 1 2 1 160 digits तक. So I can write 21 is repeated for 80 times, and the repetitions are complete. Complete 80 repetitions हुआ. Suppose I'll say 159 digits. So 2 1 2 1 2 1 2 1 last को फिर एक 2 रह जाएगा. Those kind of numbers are not symmetric. तो symmetry का मतलब है the repetitions must be complete. Repetitions must be complete. Only then we'll call it as a symmetric number. And then this condition 10 to the power n divided by the divisor. You'll have to figure out a power of 10. मैं यहाँ पे देख रहा हूँ 10 to the power 2 divided by 99, the remainder is 1. So expand in n digits. तो n का वैल्यू यहाँ पे 2 आ रहा है. तो तुम्हारा रिपीटिंग यूनिट में 2 डिजिट रहेगा. मेंटेनिंग द सिमेट्री. तो मैं अगर रिपीटिंग यूनिट में 2 डिजिट ले रहा हूँ, सिमेट्री मेंटेन भी हो रहा है. इसके बारे में अभी बहुत ज्यादा मत सोचो. जस्ट कीप इट सिंपल. But know this, that not every time this can be applied. That's the reason I'm saying this. Let us not complicate it at once. अभी के लिए ये सिंपल रखते हैं. Gradually when we'll get to difficult questions, I'll explain ये कब कैसे आता है. अभी के लिए बस माइंड में इसको रखो that there are some conditions which need to be met for this shortcut to be applied. But as far as this question is concerned, I have directly given you this question which has already met all the conditions of the shortcut. तो तुम्हें बस directly use करना है. And ऐसे ही questions exam पे आएंगे. एग्जाम में बहुत लेंथी करके क्वेश्चन देगा नहीं. Okay, so let us see another question like you will be able to relate better. Let's see the second one. 253 253 253 till 900 digits is divided by 90. थोड़ा पेशेंस रख के इसको सुनना. Don't be in a hurry to like conclude that this is something difficult and I should skip this. That's not the reason of like doing these sessions. I want all of you to take interest and understand this, if not for anything, for knowledge. Okay, for knowledge से try and understand. कहीं ना कहीं कैसे ना कैसे वो काम में आएगा. The exam is not always so objective. यही आ रहा है, यही पढ़ेंगे, वो हो जाएगा. It's not always like that. Okay, even if you are solving questions from one chapter, your experience of solving other chapters does matter. Okay, it enhances your thinking process, your ability to relate and recollect what you have practiced. That will come to your use when you are solving it. So everything matters. Take interest and solve. no need to like get into very difficult lengthy questions and जैसे भी वो सारे questions करेंगे. That's not the objective. The objective here is to learn. So now let's take a look at this. So first, is this number symmetric? Yes. यहाँ पे repeating unit is 253. Repeating unit is 253 and 253, 253, 253. Number of repetitions, if you see, number of repetitions, it is like 300 times. 3 digits are repeated up to 900 digits. तो 300 टाइम्स रिपीट हो रहा होगा. एंड यहाँ पे डिवाइजर क्या है? डिवाइजर इज 999. तो नंबर तो सिमेट्रिक है ही. एंड आई एम सीइंग दैट 10 to the power 3 divided by 999 रिमाइंडर इज 1. So I get the value of n as 3. That means I should expand in 3 digits. एंड जब मैं 3 digits में expand कर रहा हूँ, that means repeating unit में मैं 3 digit लूंगा. तो वो perfectly satisfy हो रहा है. अब ये कब satisfy नहीं होता पता है? सपोज मैं ये 999 की जगह अगर मैं 99 देता फॉर एन एग्जाम्पल, तो इन दैट केस n वुड हैव बीन 2. n 2 होगा तो तुम्हें 2 डिजिट में एक्सपैंड करना पड़ेगा. एंड जब तुम 2 डिजिट में एक्सपैंड करोगे, विल द सिमेट्री बी मेंटेन्ड? नो, क्योंकि एक बार 2 5 देन और एक बार 3 2, तो वो तो रिपीटिंग यूनिट है नहीं. तो उस केस में क्या करेंगे? आई टेल दैट इन अनदर क्वेश्चन, बट अभी के लिए इट्स क्वाइट सिंपल क्वेश्चन. इफ आई एम एक्सपैंडिंग इन 3 डिजिट्स, द सिमेट्री इज मेंटेन्ड. So directly I can write the remainder is repeating unit into the number of repetitions divided by the divisor. So simple process, you will directly get the remainder. 253 into the number of repetitions is 300 divided by 999. So 253 into 3, it is 759, then 00 divided by 999. And again we know remainder has to be less than the divisor. तो यहाँ पे remainder कितना आएगा? There is 999, so you take 3 digits from the right and put a divider. So 900 plus 75, we get 975. This is the answer. This is the remainder. Very simple process. जब 99 था तो you took 2 digits from the right and you were putting a divider. When it is 999, you take 3 digits from the right and put a divider. That is it. Okay, so this is a shortcut to calculate the remainders when you are dividing it by 9 or 99 or 999, like that. But this formula always keep in mind. Repeating unit into number of repetitions divided by the divisor. We could have solved it using this method also, like expand करके and all. But क्यों चाहिए? हमें already पता है shortcut कैसे है, तो we can directly apply. Now, most of you would be having little concerns about this. So let us take a question to understand how this condition of the shortcut it works. So for an example, I'll take this same question only, but I'll change the divider. Find the remainder when 253, 253, 253 up to 900 digits, everything is same, 900 digits is divided by, I'll take it as 99 now. I'll not take as 999, I'll take it as 99. So is the number symmetric? First condition of the shortcut, symmetry is maintained. But I am taking 10 to the power 2 divided by 99, remainder is 1. But n cannot be 2. n 2 नहीं हो सकता, because n 2 हुआ तो repeating unit में 2 digit चाहिए, but repeating unit तो 253 है, 3 digits. So if 10 to the power 2 नहीं हो रहा है, I'll go with the next power जहाँ पे 2 आएगा, तो 10 to the power 4 divided by 99 I can do. और 10 to the power 4 लेंगे तो n equal to 4. If I'm taking 4 digits, do I get the repeating unit? 2532, फिर 5325 नहीं हो रहा है. Then I'll figure out the next power, 10 to the power 6 divided by 99. Here n is equal to 6, and if I'm taking 6 digits, 253, 253, here the symmetry is maintained. तो समझ रहे हो कहाँ चेंज हो गया क्वेश्चन? जब 999 था, 3 डिजिट परफेक्टली सिंक हो रहा था. फर्स्ट क्वेश्चन 2 9 2 डिजिट परफेक्टली सिंक. बट हियर डिजिट जो रिपीट हो रहा है वो 3 डिजिट्स रिपीट हो रहा है, बट डिवाइजर में 2 9 है. So that is why you need to take the LCM type of 3 and 2 है तो I'll go for 10 to the power 6. So in this case, what is my repeating unit? Although 253 is repeated, but for solving the question, my repeating unit is 253, 253. 6 digits I have to take. And the number of repetitions in this case, if you look at this number of repetitions, 906 digits are repeated, so 150 times. And the divisor here is 99. Just little tweak to the solution part, baki everything is same. So remainder is repeating unit 253, 253 into the number of repetitions, that is 150 divided by 90. फिर इसको सॉल्व करके आंसर तो आ ही जाएगा, बट आई होप इट मेक सेंस नाउ कैसे इसको सॉल्व करते हैं. तो यू कैन मल्टीप्लाई इट फर्स्ट. तो 15 3 जा 45, या नहीं तो इसको पहले यहाँ पे तुम ऐसे ब्रेक कर सकते हो. So when 150 is divided by 99, the remainder is 51. But इसको जब 99 में डिवाइड करो, you break it into parts. 25 plus 32 plus 50. So 25 plus 32, 20, 30, 50, 50, 100, and 5 to 7, 110. So I'm getting 110 into 51 divided by 99. 110 divided by 99, the remainder is actually 11. 11 into 51, 11 1 is 1, carry 1. 11 5 is 55, 150. 561 divided by 99, and you again divide this. So the remainder is actually 60. थोड़ा यहाँ पे कैलकुलेशन लंबा हो गया, बट प्रोसेस तो वही है. रिपीटिंग यूनिट इनटू नंबर ऑफ रेपिटेशंस डिवाइडेड बाय द डिवाइजर. एंड यहाँ पे कैसे, लाइक हियर आई टोल्ड यू टेक 2 डिजिट्स फ्रॉम द राइट एंड पुट ए डिवाइडर. ए बी सी डी था तो 2 डिजिट्स, तो ए बी प्लस सी डी. बट यहाँ पे 6 डिजिट्स आ गए, बट नो प्रॉब्लम, आई विल फॉलो द सेम प्रिंसिपल इवन इफ इट इज 6 डिजिट्स. ए बी सी डी ई एफ हो गया डिवाइडेड बाय 99. तो दो दो डिजिट में डिवाइडर पुट करो, तो यू गेट ए बी प्लस सी डी प्लस ई एफ. दिस इज योर रिमाइंडर. एंड अगर वो 99 को एक्सीड कर रहा है तो फिर से डिवाइड करो, बिकॉज रिमाइंडर इज ऑलवेज लेस देन डिवाइजर. you'll have to watch the first two theorems to be able to relate to this properly. जो लोग पहले दो theorems देखे हो, you will be able to understand this. And if you have not watched the first two theorems, I have linked the first two theorems in the description of the video. Do watch them. Okay, you will find these easy. I'm not saying ऐसे questions exam में definitely आएगा, but अगर भी आ रहा है and तुम एक बार इसको समझ गए, you look at what is the solving like magnitude. Only two steps. See, two steps. Repeating unit into number of repetition. बस वही figure out करना है. That is it. So easy. This is an easy question. We cannot put it under difficult question. Yeah, if you have not solved these questions before, it will come under difficult question category. But नहीं, काफी easy question. Okay. Let's take a look at this one. यहाँ पे again we'll follow the same principle. That here is the number symmetric. Symmetry, yes. 4246, 4246, 800 digits तक है. Then I'll have to figure out a power of 10 which divided by the divisor, the remainder is 1. I am seeing 10 to the power 2 divided by 101. It is like 100 divided by 101. The remainder is minus 1. Is 1 less, so minus 1 आएगा remainder. तो अगर मैं 10 to the power 4 ले रहा हूँ, so it is like 100 into 100 divided by 101. Minus 1 and minus 1. Overall remainder is 1. So I can take n as 4. And if n is 4 and I am expanding in 4 digits, तो वही repeating unit भी हो रहा है. So both the conditions are met. So here I can say, okay, my repeating unit in this case is 4246. Number of repetitions, if you look at it, 4 digits and 800 digits तक repeat हो रहा है, तो 200, and the divisor here is 101. Hence the final remainder is repeating unit 4246 into number of repetitions divided by the divisor. अब कैसे सॉल्व करें? अभी तो सॉल्व हो जाएगा, बट इसका भी एक शॉर्टकट है. What is the shortcut? Let me write it here and then we'll come back to the solution. Whenever you multiply any two-digit number with 101, any two-digit number when multiplied to 101, it will just simply repeat itself, AB, AB. Any two-digit number multiplied with 101, it will just simply repeat itself, AB, AB हो जाएगा. So for an example, I'll write 47 into 101. It is 4747. 56 into 101. It is 5656. 23 into 101. It is 2323. Okay. Very simple property about 101. Any two-digit number when multiplied to 101, it will just repeat itself. So now if you look at this, यहाँ पे ये जो 4246 है, let's take a look at this number. This 4246, I can write it as 4242 plus 4, and this 4242 is now 42 into 101 plus 4. तो 4246 में अगर 4242 होता तो it would have been 42 into 101. 42 into 101 is like 4242, but this is 4246, तो रिमाइंडर कितना हो गया? प्लस 4. It is 4 more plus 4. And what is the remainder here? ये 200 है, ये 101 है. 101 into 2 would have been 202, but ये 200 है, 2 less, so remainder is minus 2. So plus 4 into minus 2, the remainder is how much? Minus 8, because this is a product, so multiply करो. Minus 8 is the negative remainder. How do you make it positive? Now minus 8 plus 101, get 90. To make a negative remainder positive, add the divisor. I had told this. Add the divisor. Add the divisor to make a negative remainder positive. To make a negative remainder. Simple principle है, but इसको जानना पड़ेगा. Then only you will find these questions very easy. Add the divisor to make a negative remainder. I hope this is clear. Simple सा question है. But same logic. Repeating unit into number of repetitions divided by the divisor. So 101 भी is a possible divisor in such kind of questions, and ये property use हो रहा है. Any two-digit number into 101, it will just simply repeat itself. If you look at this one, again similar type of question. First condition is symmetry maintained. Look at this question. Is there symmetry in the number? 524 529 524 529. 6 digits repeat हो रहा है till 1500 digits. Symmetry तो है ही. 250 times complete repetition हो रहा है. But now the divisor is 1001. तो मैं जब 10 to the power 3 divided by 1001 करता हूँ, this 1000 divided by 1001, and the remainder is minus 1. So when I take 10 to the power 6 divided by 1001, this 1000 into 1000 divided by 1001, minus 1 into minus 1, I get remainder 1. So I can take n is equal to 6. And when I take n equal to 6, I'll have to expand in 6 digits, and 6 digits में if you are expanding, symmetry is maintained. So you can say the repeating unit in this case, repeating unit is 524 529. Number of repetitions is एक repeating unit में 6 digits है and 1500 digits तक है, तो 1500 by 6, 250 times repetition हो रहा है, and the divisor is 1001. So the remainder is repeating unit 524 529 into the number of repetitions is 250 divided by 1000. अब इसको कैसे सॉल्व करेंगे? Just like उसमें था ना AB into 101, here also we have another property. This ABC, any 3-digit number into 1001 will just simply repeat itself. ABC, ABC. Any 3-digit number into 1001 will just simply repeat itself. So 129 into 1001, suppose you are doing, it is 129 129. 703 into 1001 is 703 703, and so on. Very simple logic. Any 3-digit number into 1001 will just simply repeat. And 1001 is quite an interesting number. It is a product of 3 consecutive primes, 7 into 11 into 13. Okay. So some level of comfort you should have with numbers. The moment you see such some numbers, you should be able to identify. This is 1001 इतना हो गया. Similarly, I can say 999 is 27 into 37. इसको एग्जाम में और फैक्टराइज करना नहीं. दैट इज द मीनिंग ऑफ प्रिपरेशन. नंबर देखते ही माइंड में आ जाना चाहिए, बिकॉज दैट इन्फरेंस दैट यू ड्रॉ इमीडिएटली that is somewhere linked to the approach of the question. If you can figure out the number, वो number related something approach में ही रहेगा जैसे भी. But if I'm clueless about the question, that means I'm not prepared enough. Okay, so initially you will find a lot of new things. Some things will come easy to you, some things will be difficult, but do not give up. Try and involve yourself in that. Why is this concept being like this? मैं ये question में कैसे use हो रहा है, थोड़ा सोचना पड़ेगा. Because this is an application based exam, not only a concept based exam that I learn this and directly put the formula, get the answer type. नहीं है, थोड़ा सोचना पड़ता है, involve होना पड़ता है. So take interest and do this. You'll definitely see that you'll find it easy. Anyways, any 3-digit number into 1001, it will just simply repeat itself. So if I use that logic in this case, now think about this. 524 into 1001 would have been 524, 524. That means 524, 524 is divisible. So 524, 529 आएगा तो remainder कितना आ जाएगा? 5, क्योंकि it is 5 more. And here the remainder is 250, क्योंकि 250 anyways 1001 से divide करोगे तो ये already less है, तो क्या ही divide करेंगे? Now you multiply it. 250 into 5, I get 1250 divided by 1001. So the remainder is 249. कितना सिंपल क्वेश्चन है, देख पा रहे हो? जस्ट 2 steps, 3 steps. तो एक बार इसको समझना थोड़ा लेंथी हो सकता है, बट वंस यू अंडरस्टैंड दिस, you cannot find easier questions than this. That is why I said in the beginning of the reminders portion, reminders can be lengthy to understand because so many things, so many new formulas, theorems are there, but it can be very handy if you have time and you learn this properly. Because जो 2023 के लिए तुम अभी प्रिपेयर हो रहे होगे and you learn this from now, you will have some time to adapt, to practice, and एक दो महीने में you will completely get the hang of it. I'm not saying for 2 months keep practicing reminders, not at all. The concepts, once we learn that, it sometimes we need time to process it. एक दो क्वेश्चन सॉल्व भी हो जाएगा, कभी कभार फंसेंगे, कभी कभार भूल जाएंगे, अगेन विल रिवाइज, एंड दैट प्रोसेस नीड्स टू बी लाइक गॉन थ्रू. तभी जाके यू विल रिलेट टू द कॉन्सेप्ट बेटर व्हेन यू सी द क्वेश्चन. तो अभी से अगर तुम इसको पढ़ के कैपिटलाइज करोगे, ट्रस्ट मी, यू सी अ क्वेश्चन फ्रॉम रिमाइंडर्स इन द एग्जाम जो कि मैक्सिमम टाइम्स आर ऑन द इजियर साइड, यू विल बी एबल टू सॉल्व, एंड दैट वन पार्ट यू नेवर हैव टू वरी अबाउट एवर अगेन. एंड नंबर्स में कॉन्फिडेंस लाने के लिए दिस इज अ वेरी बिग बूस्ट. ओके, so this is one category of continuous digits remainder questions which are based on basic remainder theorem. यहाँ पे मैं कोई theorem पे नहीं आ रहा हूँ, जैसे शॉर्टकट हमने डिराइव किया. इवन इफ यू डोंट नो, दिस इज द डेरिवेशन. क्यों रिपीटिंग यूनिट इनटू नंबर ऑफ रेपिटेशंस हो रहा है? आई होप ऑल ऑफ यू आर एबल टू रिलेट टू इट नाउ. तो ये एक पार्ट हो गया कंटिन्यूस डिजिट्स का क्वेश्चन. देयर इज अनदर एस्पेक्ट टू दीज काइंड ऑफ क्वेश्चंस व्हिच इज समथिंग लाइक दिस, एंड दिस इज काइंड ऑफ लिंक्ड टू फॉर्मेट थ्योरम. If you have missed the Fermat theorem, I'll pin that also. Description में तो दोनों के दोनों videos pinned है, but Fermat theorem I have pinned in the I section. From this point you can watch Fermat theorem. पहले वाला part था basic remainder theorem का, अभी from this point watch Fermat theorem. इसका भी एक direct shortcut है, and you can do it in 5 seconds. This question can be solved in 5 seconds. Okay, this question can be solved in 5 seconds. तो Fermat theorem का extension है this. So these are the 3 principles that you need to know to solve such kind of questions. I'll derive one of them, but उसके बाद you just need to know these 3 rules, and those questions 5 seconds में you will solve. First principle, any digit a when repeated for 2p minus 1 times and when it is divided by p, the remainder is the digit itself. Note that p is a prime number. P has to be prime number. क्योंकि फॉर्मेट थ्योरम है तो p तो प्राइम नंबर होगा ही. तो कोई भी डिजिट को अगर मैं 2p minus 1 टाइम तक रिपीट करता हूँ, एंड व्हेन आई एम डिवाइडिंग इट बाय p, द रिमाइंडर इज द डिजिट इटसेल्फ. जैसे यहाँ पे देखो 23 में इस 23 इज द प्राइम नंबर p, एंड 45 2 into 23 minus 1, that means 2p minus 1 times हो रहा है. So the digit 5 is repeated 2p minus 1 time, and when this is divided by 23, the remainder is simply 5. तो कुछ सॉल्व नहीं करना, देखना है 5 रिपीट हो रहा है कितना टाइम, 45, तो 2p minus 1 हो रहा है, direct remainder is 5. Similarly, when it is repeated 2p minus 2 times, the remainder is 0. जैसे यहाँ पे 19 is p and 36 is like 2p minus 2, 2 into 19 minus 2. तो अगर 2p माइनस 2 टाइम्स रिपीट हो रहा है, रिमाइंडर 0। एंड नॉट जस्ट 2p माइनस 2, एनी मल्टीपल ऑफ 2p माइनस 2 भी अगर हो रहा है तभी भी रिमाइंडर 0 है। जैसे 36 डिजिट्स में रिमाइंडर 0 है, 72 में भी रिमाइंडर 0 आएगा, 108 में भी रिमाइंडर 0 आएगा, एंड और एनी मल्टीपल ऑफ 36। तो इन जनरल एनी मल्टीपल ऑफ 2p माइनस 2 टाइम्स भी रिपीट हो रहा है तो रिमाइंडर। So if you know these three principles, you will solve these kind of questions in 5 seconds. Just look at the question and answer. Okay. But I'll derive this rule for you to understand कि हो कैसे रहा है. So let me write it here that remainder of this 7, 7, 7. You don't need to remember the theorem. Okay, just for understanding, I'm deriving this up to 37 digits. This divided by 19. So this 7, 7, 7 up to 32 digits. ये जो है 37 digits. I can write it as 7 by 9 whole into 999 up to 37 digits. कि 9 इसमें डिवाइड हो जाएगा तो 111 हो जाएगा, उसमें 7 मल्टीप्लाई होगा तो सारे 7 आ जाएगा. So this will be 7 by 9. This I can write it as 10 to the power 37 minus 1. क्योंकि तुम देखो ऐसा यहाँ पे जब मैं एक 9 ले रहा हूँ it is 10 to the power 1 minus 1. But taking 2 9s it is 10 square minus 1. So likewise 37 times 9 है तो 10 to the power 37 minus 1. Now what you do is this 10 to the power 37 में एक minus 10 एक plus 10 करो. Derivation is just for your understanding. I am not pressurizing you to remember the derivation. Not needed. मैं उसका generalizations already बोल दिया हूँ तो just look at the question and answer. But this is for your own understanding कि कैसे ये processes बनते हैं. So 7 by 9 from the first two terms you take 10 common and you get 10 to the power 36 minus 1 and second last दो ये term में 10 minus 1 9 हो गया. Now you open the bracket. So you get 7 by 9 into 10. Is 10 to the power 36 minus 1. Can I write it in this way? 10 to the power 18 plus 1 into 10 to the power 18 minus 1. A minus b into a plus b. समझ आ रहा है? A minus b into a plus b कर लिया तो a square minus b square फॉर्म में आ जाता है. This is a minus b into plus b. a square minus b square था. I broke it down like this. And this 7 by 9 into 9, it will result in 7. Now multiply this 10 here. So you get 7 by 9 into 10 to the power 18 plus 1 into 10 to the power 19 minus 10 plus 7. Now think about this. When you divide this total number by 19, 7 by 9 to 10 to the power 18 plus 1 into 10 to the power 19 minus 10 plus 7 divided by 19. तो रिमाइंडर कितना है? Now in Fermat's theorem we learnt that remainder of a to the power p minus 1 divided by p is a, sorry, is 1. ये बोल रहा हूँ. अगर a to the power p minus 1 में रिमाइंडर is 1, a to the power p minus 1 if the remainder is 1, so I can write remainder of a to the power p divided by p will be remainder of a into a to the power p minus 1 this divided by p. तो यहाँ पे तो रिमाइंडर 1 हो जाएगा तो ये आ रहा है a. तो 10 to the power 19 minus 10 जब करोगे तो यहाँ पे देखो 10 to the power 19 minus divided by 19 remainder is 10. यहाँ पे भी remainder is 10. So this overall remainder is 0. So I can write remainder of 10 to the power 19 minus 10 divided by 19. The remainder is 0. तो अगर ये रिमाइंडर पूरा 0 हो जाएगा, only thing left is 7. So you are left with 0 plus, because this term 10 to the power 19 minus 10 is divisible by 19. So you can generalize in this way. जैसे ये Fermat's theorem का रूल है a to the power p minus 1 divided by p remainder is 1. You can also write remainder of a to the power p minus a divided by p the remainder is 0. This is also another conclusion of Fermat. तो वही चीज यहाँ पे यूज हुआ। 10 to the power 19 minus 10 डिविजिबल है, तो वो पार्ट का रिमाइंडर 0, तो बस 7 रह गया। यू डोंट हैव टू रिमेंबर दिस डेरिवेशन एट ऑल, ये नीडेड ही नहीं है। तो यहाँ पे हमने क्या देखा है, यहाँ पे जो 7 7 7 37 डिजिट तक रिपीट हो रहा है, जब उसको तुम 19 में डिवाइड कर रहे हो, रिमाइंडर इज 7 इटसेल्फ, लास्ट को तो वही रहा, तो इतना क्यों करना बार बार, ये समझने के लिए फॉर आवर ओन अंडरस्टैंडिंग वी हैव डन दिस। बट नेक्स्ट टाइम यू सी अ क्वेश्चन लाइक दिस, जस्ट रिमेंबर दिस प्रिंसिपल that if any digit a is repeated for 2p minus 1 times, when it is divided by p, the remainder is the digit itself. तो जो भी digit repeat हो रहा है वो वही है remainder, बट वो कंडीशन देखना है कि p प्राइम नंबर है, डिवाइजर p है, 2p minus 1 टाइम्स रिपीट हो रहा है। जब 2p minus 2 टाइम्स रिपीट हो रहा है, रिमाइंडर इज 0, और एनी मल्टीपल ऑफ 2p minus 2 हो रहा है तो भी रिमाइंडर। दीज आर वेरी 3 इंपॉर्टेंट प्रिंसिपल्स, वेरी इंपॉर्टेंट। तो इसको माइंड में रखोगे तो सच काइंड ऑफ क्वेश्चन 5 सेकंड, वी डोंट हैव टू सॉल्व दिस थिंग, जस्ट देखेंगे क्वेश्चन, आंसर करेंगे। फॉर एन एग्जाम्पल लेट अस टेक ए लुक एट दिस वन। यहाँ पे देखो ये नंबर है टिल 99 डिजिट, दिस इज 17, तो यहाँ पे p प्राइम 17 है, तो 2p माइनस 1, तो 34 माइनस 1 33 है, एंड 2p माइनस 2 इज 32। तो ये 99 डिजिट्स आई कैन राइट इट इन दिस वे, 333 अप टू 99 डिजिट्स डिवाइडेड बाय 17। इसको ऐसे लिख सकते हैं 333 अप टू 96 डिजिट्स। व्हाई डिड आई टेक 96? बिकॉज मेरे को 32 डिजिट्स में रिमाइंडर 0 मिलेगा, 32 में रिमाइंडर 0 और एनी मल्टीपल ऑफ 32 आल्सो रिमाइंडर 0, सो 96 इज अ मल्टीपल ऑफ 32, तो आई नो टिल दिस 96 डिजिट्स द रिमाइंडर इज 0, तो उसी को यूज करेंगे। बट नंबर तो 99 डिजिट्स है, तो और 3 एक्स्ट्रा डिजिट्स चाहिए, तो क्या करेंगे, आई विल मल्टीप्लाई 10 to the power 3। तो आई हैव अ नंबर टिल 96 डिजिट्स, उसमें 10 to the power 3 मल्टीप्लाई किया, तो लास्ट में 3 जीरो आ गए, बट जीरो तो नहीं है, सारे डिजिट्स 9 है, तो उसमें तुम 999 ऐड कर लो, दिस डिवाइडेड बाय 17। नाउ थिंक अबाउट दिस, द रिमाइंडर हियर इज 0, तो ये पूरा 96 डिजिट्स तक इट डजंट मैटर, यू आर जस्ट वरीड अबाउट द लास्ट 3 डिजिट्स, बस उतना ही सॉल्व करना है। देख रहे हो कितना इजी है, तो जस्ट यू डिवाइड 999 बाय 17 एंड फाइंड द रिमाइंडर, जो भी आएगा। 17 5 85, तो 14 आ गया, 149, 17 into 8 is 136, तो ये 149 है, तो रिमाइंडर आई थिंक 39। मेक सेंस? तो 99 डिजिट, जैसे ही 99 देखोगे तुम, 17 है तो 32 2p माइनस 2, उसमें रिमाइंडर 0 है, तो 64 में 0 होगा, 96 में 0 होगा, तो 96 डिजिट तक तो रिमाइंडर 0 है, जस्ट लास्ट को और 3, तो उसी को ही डिवाइड करना है। द रेस्ट अदर डिजिट्स 96 डिजिट्स दे डोंट मैटर, ओनली लास्ट 3 डिजिट्स विल मैटर। That is how easy these questions are once you understand them. I'm not saying very important this, but definitely तुम्हारा knowledge and your ability to think on reminders will improve if you know this. Okay, तो एक बार तो बनता ही है पढ़ना these things, and I'm doing this very early so that you don't have to worry about these theorems and all later on. तो अभी से पढ़ लो and अभी से इसको समझ लो, तो you will never have to worry about reminders ever again. So that was it for this continuous digits. So this completes कंटिन्यूस डिजिट के क्वेश्चन, जितने भी टाइप के हो सकते हैं क्वेश्चंस मैंने यहाँ पे बता दिए, एंड मोर देन सफिशिएंट एज फार एज कैट एंड अदर एग्जाम्स आर कंसर्न, मोर देन सफिशिएंट टू अंडरस्टैंड। ओके, so hope all of you got some idea about how to think on these questions. If you are new to this session and you have watched this so far and you liked my way of teaching, do like the session and subscribe to the Aptitude Club channel, new content and new channel. So do support by subscribing to the channel and share it with your friends also who are Cat 20 aspirants. If you have missed the previous 2 sessions, I have provided the description part of the video. I have provided the links, and you can check out the previous 2 sessions on reminders. This is going to be a full playlist total on the concept of reminders. Gradually going ahead, I'll create a playlist on different topics. For example, polynomials में, functions में, एंड ये रिमाइंडर्स हो गया। सिमिलरली टाइम स्पीड डिस्टेंस का प्लेलिस्ट, टाइम एंड वर्क, each topic I'll create different playlists, so that end to end, from basic to advanced level, you will get an idea how to think on those concepts, think on those topics, and then practice questions. So thank you once again for joining me in this video. Do like and subscribe to the Aptitude Club channel. We'll meet again very soon in yet another video. Till then, have a nice day. Thank you.